In Chapter 7, we're going to be studying linear systems. In Section 7.2, we're going to learn how to solve a system of linear equations graphically. What is a linear system? A linear system is a group of two or more linear equations. To solve a system means to find their intersection point. In this section, we'll learn two methods to solve graphically, but you will get to decide which one you want to use. Two equations in a linear system are graphed on the same grid. What are the equations of these graphs? And what are the coordinates at the point of intersection of these two lines? So again, this is building off some of our skills from last chapter. So if we take a look at the red line, again, we have the general equation y equals mx plus b, which is the slope-intercept form. We see that the y-intercept is plus 5, and we see that the slope of the line is plus 1. So the equation of the red line would be y equals x plus 5. For the blue line, again, we'll start with y equals mx plus b. Again, the y-intercept is plus 1, and this time my slope is negative 1. So my equation would be y equals negative x plus 1. Now, the coordinates of the intersection point is the point negative 2, positive 3. And that would be the solution to this linear system because negative 2, positive 3 belongs to both lines. It makes both equations true, and that is the intersection point of the two lines. So the solution is basically the intersection point. So say we want to solve the following system using the mini table method. Okay, when I use the mini table method, all I'm going to do is I'm going to plot a table of values, and I'm going to pick values for x and y. So for example, if I let y equals 0, I'm going to get 2x plus 2x is equal to 2. And if I divide both sides by 2, I'm going to get x equals 1. So I'll just show you here. So I get 2x plus 0 is equal to 2. So 2x equals 2. Divide both sides and x is 1. So there's my first point. Okay, so now let's try another point. What if x is 1? Oh, sorry, we already did that one. What if x is negative 1? I'm going to get 2 times negative 1 plus y is equal to 2. So negative 2 plus y is equal to 2. And if I add 2 to the other side, I'm going to get y equals 4. And when using the mini table method, you should always pick 3 points. So let's pick a y being 2. So I'm going to get 2x plus 2 is equal to 2. If I subtract the 2 to the other side, I get 2x equals 0, and divide by 2, and x is 0. So now I have 3 points that I can plot. Okay, so my first point is 1 and 0. So when x is 1, y is 0. And my next point is negative 1 and 4. So when x is negative 1, y is going to be 4. And our other point was that when x was 0, y was 2. So again, get out a ruler. It's very difficult on this program for me to draw a straight line, but get out your ruler and draw the best straight line that you can. Okay, and there would be the equation 2x plus y is equal to 2. So now we're going to do the exact same thing with our next mini table, but we're going to do this one in red. So again, x and y. Again, if I let y equals 0, the negative 2y drops off, and I'll be left with x equals 6. So that one's pretty easy to do by inspection. If I let y equal negative 1, I'm going to get x minus 2 times negative 1 is equal to 6. So I get x plus 2 is equal to 6, and x will be 4. So when y is negative 1, x is 4. And when y is negative 2, let's put a negative 2 in for y. It's going to be x minus 2 times negative 2 equals 6. So negative 2 times negative 2 is plus 4. And if I subtract, x is going to be 2. So those are going to be the points I will get. So now let's plot these points. So at 6, it's going to be 0. At 4, it's going to be negative 1. And the last point was when x was 2, y is negative 2. So at 2, it is negative 2. And again, if you plot that, Your graph looks something like that. And if drawn accurately, it looks like my solution is going to be the intersection point 2 and negative 2. And if you wanted to verify that, you could plug 2 in for x in the first equation and negative 2 in for y and see if it makes the equation true. So 2 times 2 is 4, 4 minus 2 is 2. Yes, it works in that one. If I put a 2 in here, I get 2 minus 2 times negative 2. Does that equal 6? Well, negative 2 times negative 2 is 4, and 2 plus 4 is 6. Yes, it works. So that is the correct solution, 2 and negative 2. Okay, in the next example, we are going to use the slope-intercept method to find the intersection point. So the first thing we need to do is get our equation in the form y equals mx plus b. So in the first equation, I'm going to subtract the 3x to the other side. And then I'm going to divide everything by negative 2. So my final equation is going to be y equals 3 over 2x plus 4. So again, for this one, I'm going to start with the y-intercept of plus 4. There's going to be my first point. That comes from my y-intercept. And my slope is 3 over 2, which means from that point, I can go up 3 and over 2. And that point would put me right here. And if I wanted to, I could do that again. I could go up 3 over 2. And again, there would be my line if I was to draw it. Okay, and again, that would be the equation y equals, well, let's put the original equation, maybe not that it matters because it's really the same thing, but that is 3x minus 2y equals negative 8. In the next equation, this one's pretty straightforward. All I do is I subtract 2x to the other side. Remember, this is really 2 over 1. So my y-intercept is negative 3, and my slope is negative 2. So I start with my y-intercept of negative 3. And my slope, I'm going to go down 2 over 1, down 2 over 1. So again, if I get out my pen and draw this line, it looks like that. So this is the equation 2x plus y equals negative 3. And again, the intersection point appears to be at the point negative 2 and 1. So again, I can verify by putting negative 2 in for x and 1 in for y. And does that equal negative 8? Well, negative 6 minus 2 is negative 8, so that's correct. Again, I could put negative 2 in for x and a 1 in for negative y. And if I add, sorry, if I multiply these together, I get negative 4. And if I put in a positive, it wants to be a positive 1 for y, sorry, negative 4 plus 1 is negative 3. This is the valid solution as well. So that coordinate is correct. So again, to find a solution to a linear system, all you need to do is you need to graph each line and find where they cross. Okay, I now encourage you to pause the video and give this one a try on your own. Okay, I hope you had a chance to try this one, and I'm going to set this up, and I'm going to use the slope-intercept method. So again, the first thing I'm going to do is I'm going to subtract the 2x to the other side, and then I'm going to divide everything by 3. Therefore, my equation is negative 2/3 x plus 1, so that means my y-intercept is plus 1. I'm going down 2 and over 3, down 2 and over 3. Again, you can get out your ruler and you can draw this line. And that is the equation 2x plus 3y equals 3. For the second line, I'm simply going to add the y over and subtract the 4. So I'm going to end up with y equals x minus 4. So my y-intercept is negative 4, and my slope is 1. So negative 4 is the y-intercept, up 1 over 1, up 1 over 1. And again, we can draw this line in. And it appears that my solution, if drawn accurately, is going to be the 0.3 and negative 1. Again, we can verify if I put a 3 in here and a negative 1 in here, I'm going to get 6 minus 3, which is 3. And if I put a 3 here and a negative 1 here, 3 minus 4 is negative 1. So that solution is correct. Okay, there's 4 questions for you to try on page 408. Give those a whirl, and if you have any questions, you can check the website for the answers.